On a quiet morning in the spring of 2025, NASA Administrator Bill Nelson stood at a podium at NASA headquarters in Washington and said something that sent a ripple through the entire scientific community. He was not talking about a rocket launch. He was not talking about a Mars mission or a budget approval. He was talking about a star, a single star, 642 light years away, sitting on the shoulder of the constellation Orion. He said, and I want you to hear these words carefully, "We are not predicting the explosion for tomorrow, but all signs point toward an advanced point in Betelgeuse's life cycle." That one sentence from the head of the most powerful space agency on Earth was enough to make astronomers worldwide stop what they were doing. Because when NASA's chief stands at a podium and talks about a star being at an advanced point in its life cycle, that is the scientific way of saying this star is dying. And when a star of this size dies, the entire observable sky changes in a way that no human being alive today has ever witnessed. The question is not whether it will happen. The question is when. And that question, as of right now, does not have a clean answer. What it does have is a rapidly growing body of evidence, a series of jaw-dropping recent discoveries, and a warning system being built right now that will alert every telescope on Earth within minutes of the moment this star begins to collapse. To understand why any of this matters, you first need to understand what Betelgeuse actually is. Most people look up at the night sky and see a bright reddish-orange dot sitting in the top left of the Orion constellation. That dot is Betelgeuse. It is the seventh brightest star in the entire night sky. On a clear night, it glows orange and red with a kind of burning intensity that even the naked eye picks up. But the numbers behind that dot are staggering. Betelgeuse is roughly 1,000 times the size of our Sun. If you placed Betelgeuse where our Sun is, it would swallow Mercury, Venus, Earth, Mars, and extend almost all the way out to Jupiter. The entire inner solar system would disappear inside it. It burns at approximately 100,000 times the luminosity of our Sun, and it is old. Roughly 10 million years old, which in stellar terms for a star this massive means it is very, very close to the end. Stars like Betelgeuse do not fade out gently. They explode. They collapse under their own gravity in a fraction of a second, and then release more energy in that single moment than our Sun will release over its entire 10 billion year lifetime. That explosion is called a supernova, and the supernova of a star this close, this large, and this bright would be the most extraordinary astronomical event any living human being has ever seen with their own eyes. Now here is where the story gets complicated, and it gets complicated in a way that makes it even more fascinating. For the past several years, Betelgeuse has been behaving strangely, and that strange behavior is what triggered NASA's warning, what has had astronomers watching the star in shifts around the clock, and what led to one of the most significant astronomical discoveries of 2025. Let me take you through the timeline, because it matters. In late 2019, something happened to Betelgeuse that nobody expected. The star started getting dramatically dimmer, not slightly dimmer, not the normal variations you see from a variable star. It dropped in brightness by approximately 60%. By February 2020, Betelgeuse had dimmed to a level that had never been recorded in over a century of careful observation. It was so dramatic that it was given a name. Scientists called it the Great Dimming. And when a star this massive dims by 60% without warning, the first question every astronomer asks is the same question. Is this the beginning of a supernova? For a few weeks in early 2020, there was genuine excitement and genuine fear in the astronomy community. People pointed telescopes at Orion from every continent. Media around the world ran headlines asking whether Betelgeuse was about to explode. And then it got brighter again. The dimming stopped. The star recovered. And scientists spent months figuring out what had actually happened. What they eventually concluded was that Betelgeuse had thrown off an enormous cloud of gas and dust, larger than the star itself, in an event called a surface mass ejection. That dust cloud blocked part of the star's light as seen from Earth, creating the appearance of dramatic dimming. It was the largest such event ever recorded on any star. Not a supernova, but not normal behavior either. This was a star doing something that no star had ever been observed doing before. Then, in 2023, Betelgeuse started behaving strangely again. Astronomers noticed that it was cycling through its dimming and brightening patterns at roughly twice its normal speed. The star pulses, it expands and contracts in regular cycles, and that pulsation rate had suddenly changed. And in early 2024, the American Association of Variable Star Observers reported that Betelgeuse had dimmed again by 0, 5 magnitudes in just the first few months of the year. All of these signs together, the great dimming, the surface mass ejection, the changed pulsation rate, the repeated dimming events, were what led to NASA's administrator making his public statement. The accumulation of unusual behavior was too consistent, too dramatic, too unlike anything seen in a stable star to ignore. But then, in July 2025, everything changed again. And this time it changed in a way that nobody had predicted. NASA's Ames Research Center team, working with the Alupec instrument on the Gemini North Telescope in Hawaii, made a discovery that had been suspected for almost a century but never confirmed. Betelgeuse is not alone. For nearly 100 years, astronomers had occasionally suggested that Betelgeuse might have a companion, a smaller star orbiting around it. There had been hints in the spectral data, small anomalies in the light patterns that could not be fully explained. But Betelgeuse is so blindingly bright that anything orbiting close to it was impossible to see through the glare. The Alupec instrument was specially designed to cut through exactly that kind of glare, using a technique that blocks out the central brightness of a star to reveal what is around it. And when they pointed it at Betelgeuse in December 2024 and then analyzed the data through early 2025, they found it, a second star. Orbiting Betelgeuse at a distance closer than Jupiter is to our Sun, a hot blue-white star with 1,4:1, 6 times the mass of our Sun. This companion was given the name Siwarha, which in Arabic means her bracelet, a poetic echo of Betelgeuse's own name, which comes from Arabic meaning the hand of Orion. The findings were published in the Astrophysical Journal Letters in July 2025 in a paper titled The Probable Direct Imaging Detection of the Stellar Companion to Betelgeuse. Carnegie Mellon University researchers followed up in October 2025 with additional details, revealing that the companion was not what scientists had expected. They had predicted it might be a white dwarf or a neutron star, a dense remnant of a star that had already died. Instead, Siwarha appears to be a young, active star, still early in its development. The Chandra X-ray Observatory found no X-ray radiation from Siwarha, which ruled out the compact remnant theory and confirmed it was a main sequence star. This is what Anna O'Grady at Carnegie Mellon called a new regime of extreme mass ratio binaries, meaning we have never seen a binary system where one star is 16 times the mass of the Sun and its partner is barely heavier than the Sun itself, orbiting so close together. This discovery changed the entire interpretation of Betelgeuse's behavior. Siwarha orbits Betelgeuse every 2,170 days, approximately 6 years. As it moves through its orbit, it plows through Betelgeuse's vast outer atmosphere. And, as it does, it creates a wake behind it, exactly like a boat moving through water creates a churning trail. That wake disturbs the gas around Betelgeuse, absorbs and scatters some of its light, and creates the long-cycle brightness variations that astronomers had been watching for years. The mysterious 2,170-day dimming cycle that had puzzled scientists for decades was not Betelgeuse signaling its own death. It was Siwarha quietly stirring the outer atmosphere as it went around. In short, the discovery of Siwarha pushed the timeline for Betelgeuse's supernova further out. Current models now place Betelgeuse in a stable helium-burning phase, with likely hundreds of thousands of years remaining before the actual explosion. But here is the critical thing to understand. Hundreds of thousands of years in human terms sounds like forever. In astronomical terms, it is tomorrow afternoon. And more importantly, scientists are now clear about one thing. The models that gave us that 100,000-year estimate could be wrong. The discovery of Siwarha itself proves that our models were incomplete. If we missed an entire companion star for 100 years, what else are we missing about Betelgeuse's internal state? The answer is, we don't know. And that is exactly why NASA's warning was serious and why the monitoring of this star has intensified rather than relaxed. Here is something that almost nobody talks about when they discuss Betelgeuse, and it is the part of this story that I find most fascinating. There is already an early warning system in place. It is called SNOOS, the Supernova Early Warning System, and it was designed specifically to give us advance notice when any nearby star begins to collapse. Here is how it works. When a massive star like Betelgeuse begins its final collapse, something extraordinary happens in the core before anything else. The core temperature spikes to trillions of degrees. At those temperatures, the collapsing material produces an enormous burst of subatomic particles called neutrinos. Neutrinos are almost impossibly small, travel at nearly the speed of light, and pass through virtually everything without stopping. When a star collapses, it releases more neutrinos in 10 seconds than our Sun has released in its entire 10 billion year lifetime. And because neutrinos travel at nearly the speed of light and pass through the star itself without being absorbed, they escape the collapsing core immediately. The light from the explosion, on the other hand, takes hours to fight its way through the star's outer layers before it can escape. This means that when Betelgeuse begins to collapse, neutrino detectors on Earth will catch a burst of particles arriving hours before anyone can see anything in the sky. The most powerful neutrino detector on Earth is supergiant in Japan, a tank containing 50,000 tons of ultra-pure water, buried deep underground. When Betelgeuse collapses, supergiant alone is expected to detect tens of thousands of neutrinos in a matter of seconds. That burst will immediately trigger SNOOS, which will alert observatories around the world within minutes. Every telescope on Earth will be pointed at Orion before the light show even begins. And there is also the gravitational wave dimension. LIGO in the United States and Virgo in Europe are designed to detect ripples in space-time. A stellar collapse the size of Betelgeuse would send gravitational waves toward Earth that would be detected nearly simultaneously with the neutrino burst, allowing scientists to triangulate the exact position of the explosion to within about 1 degree on the sky. Michael Shera, the curator of astrophysics at the American Museum of Natural History, summed it up this way. If someone gives him enough money, he will build a neutrino detector large enough to give us several days of advance warning, not just hours, before Betelgeuse's light reaches us. Several days. The science to do this already exists. And what would actually happen when Betelgeuse explodes? What would people on Earth see? The answer is something that is genuinely difficult to fully imagine. Betelgeuse right now is a bright dot in the night sky, noticeable, but not overwhelming. When it goes supernova, it will suddenly become something completely different. Astronomers estimate it would reach a visual magnitude of around -12, 5. To put that in perspective, the full moon has a magnitude of around -12, 7. So Betelgeuse would blaze in the sky at nearly the same brightness as the full moon, except it would be a point of light, not a disk. It would be visible in broad daylight. It would cast shadows at night. It would be so bright that it would be difficult to look at directly. NASA's science communicator, Dr. Michelle Thaler, described it as the most gorgeous natural occurrence anyone alive today would ever witness. It would remain bright enough to see in the daytime sky for weeks, possibly months. At night, it would dominate the sky for months. And it would remain visible to the naked eye for years as the expanding cloud of debris gradually faded. A nebula would be left behind, a glowing, expanding shell of gas and dust that astronomers would study for centuries. At the center of that nebula, a neutron star would form, an object barely 20 kilometers across, but containing more mass than our entire sun, spinning hundreds of times per second, sending beams of radiation sweeping across the galaxy. That spinning neutron star is called a pulsar. And it would be the closest and most easily studied pulsar in the entire galaxy, visible in our sky for the rest of human civilization. There is another fascinating wrinkle to this story that emerged from the Siwarha discovery. The companion star is not safe from what is coming. Siwarha currently orbits Betelgeuse at a distance of roughly 4 astronomical units, closer than Jupiter is to our Sun. Betelgeuse's gravity is already slowly pulling Siwarha inward. Models suggest that within 10,000 years, Betelgeuse will have dragged Siwarha so close that it will swallow the companion star entirely. But if Betelgeuse goes supernova before then, and it might, the explosion will obliterate Siwarha in a fraction of a second. Jared Goldberg, an astrophysicist at the Flatiron Institute, said that Betelgeuse and its companion will hug eternally, though not in a gentle way. And if Siwarha survives the explosion somehow, the force of the supernova blast would catapult it across the galaxy at enormous speed, becoming what astronomers call a hypervelocity star, a star moving so fast it can escape the gravitational pull of the Milky Way entirely. In either case, Siwarha does not have a peaceful future. It is orbiting one of the most violent stars in our neighborhood, and its fate is already determined by forces far beyond its control. The other thing worth understanding is the sheer scale of what a supernova does. When Betelgeuse collapses, the outer layers of the star, everything outside the core, will be blasted outward at a significant fraction of the speed of light. The explosion will release energy equivalent to roughly 10 to the power of 44 joules. That number is so large it is essentially meaningless in everyday terms, but here's a way to think about it. Our sun, over its entire 10 billion year lifetime, will release approximately 10 to the power of 44 joules of energy. Betelgeuse's supernova will release that same amount of energy in approximately 10 seconds. The resulting shockwave will travel outward from the star, and over thousands of years will create a nebula many light years across. The heavy elements forged in Betelgeuse's core over millions of years, carbon, oxygen, neon, magnesium, silicon, iron, will be scattered across space. Eventually, over hundreds of millions of years, that material will contribute to the formation of new stars, new planets. The iron in our blood, the calcium in our bones, the oxygen we breathe, all of it was made in stars like Betelgeuse that exploded billions of years ago. Every atom of heavy material in your body was once inside a star. And when Betelgeuse finally goes, it will seed the galaxy with the raw material for future worlds and future life. As for Earth's safety, the science is reassuring and clear. For a supernova to pose a direct threat to life on Earth, it would need to occur within approximately 50 to 160 light years of our planet. Betelgeuse is between 550 and 700 light years away, depending on which measurement you trust. That puts it at roughly 4 times the minimum safe distance. The radiation from the explosion, gamma rays, X-rays, cosmic rays, will have dispersed enough by the time it travels 640 light years to pose no direct threat to Earth's atmosphere or to life. The light will be spectacular. The neutrinos will pass harmlessly through the planet and through every living thing on it. And then, gradually, over months and years, the brightness will fade. What will remain in the sky, where Betelgeuse once glowed orange in the shoulder of Orion, will be a new nebula and a pulsar at its heart. So where does all of this leave us? NASA's warning was not about panic. It was not an announcement that the end is near. It was something more nuanced, and in some ways more important than that. It was an acknowledgement from the world's leading space agency that Betelgeuse is in the late stages of its life, that its behavior over recent years has been unusual by any measure, that a 2025 discovery rewrote everything we thought we knew about the star's dimming patterns, and that the global scientific community has built a warning system specifically designed for this moment when it comes. We do not know if Betelgeuse will explode next year, next century, or 100,000 years from now. The discovery of Siwara pushed estimates outward, but it also reminded us how incomplete our models were. A star can hide a companion for 100 years. It can throw off a cloud of dust the size of itself. It can change its pulsation rate without warning. And it can go supernova at any moment in geological time, which, from a human perspective, could be tomorrow morning. What we do know is this. When Betelgeuse finally goes, humanity will have advance warning. Neutrino detectors will fire, alerts will go out, telescopes worldwide will turn to Orion, and, for the first time in recorded human history, we will watch a nearby star explode in real time, from the very first neutrinos to the final fading glow of its nebula. It will be the most watched, most studied, most extraordinary natural event our species has ever witnessed. And we are already ready for it.